Okay, here's some solutions. Your solutions may vary. So I like to do vertical transformations. So I'm going to do a vertical shift. Let's plug in what we know. Secant 5 plus k. No point in evaluating secant of 5. Let's just keep it as secant 5. Perfectly lovely number. Cool. Done. So k is 10 minus secant 5. And actually, I think we'll probably see in a second that this might have been silly. 10 minus secant 5. So if you look at this expression, it's maybe you could see that we didn't need to do all the algebra. It's like, what number will give us 10 when we plug in 5? It must be 10 minus this thing, which is secant 5. So, so maybe that was obvious in retrospect. Even if it's not obvious in retrospect, like, you can always plug things in and the process will work. Cool. So that seems to have worked. It would be nice to just see in Desmos. What does that look like in a second? Let's do this one. So let me do one that I think might be hard to deal with. Let's try this. Let's do secant ax plus b. So let's have a horizontal scaling and shifting and see where that gets us. So secant, what am I trying to do? 5x plus b, and then here we've got 8 equals secant 8x plus b. Okay, so somehow, x, sorry, 5 was the x value. I'm trying to solve for the a values. Okay, so I need to find values a and b that make this pair of equations true, but the problem is the a and b are all kind of sequestered in there. Right away I want to choose some alternative transformations, but let's go ahead and try and do inverse secant of both sides. So inverse secant of 10 equals 5a plus b. Inverse secant of 8 equals 8a plus b. All right, maybe this is all right. Let's subtract. So b subtracted. So b minus b is 0. So now I've got inverse secant 10 minus inverse secant 8. And then, let's see, 5 minus 8 is negative 3a. All right, so, this isn't the prettiest thing in the world, but we've got inverse secant 10 minus inverse secant 8 divided by negative 3. And so you could solve for b as well. Just to have an alternative here, let's do a different set of transformations and see if this comes out a little bit more nicely. So I'm going to do a secant x plus b, so a vertical stretch and a vertical shift. So setting up the equation now, I've got a secant 5 plus b, and I have done this backwards. This should have been 3, and that should have been 8. So this should have been 3. All of my 3s look like 8s anyway. Anyway, you see what's happening. So where was I? So 3 is the y value. A times secant 8 is the x value. Great. Okay, so this seems a lot nicer to me, just because I don't have to do inverse secants. So I'm going to subtract them again. So 10 minus 3 is 7. B minus b is 0. So this is a secant 5 minus a secant 8. Don't wig out. We got 2 terms here. Both terms have the thing we care about. Let's factor it out. So that's a times secant 5 minus secant 8. So, maybe this wasn't a lot nicer, but that certainly seems to have done the job. So there's a. And I can substitute that back in here and then solve for, in here and then solve for b. So b is 10 minus this thing. So 10 minus this a times secant 5. There we go.